In this problem, we are given a right triangle with some information about their vertices as well as about their sides. And using this information, we have to find the maximum and minimum area of such triangle. First, let's recollect some information about the curve y equals e power negative x by 2. So this is basically a transformed curve from its parent curve, that is y equals e power minus x. So this one is a decreasing function. So it starts from a huge positive value and keeps decreasing, and it approaches 0 when x approaches infinity. So this is the general shape of e power minus x. In fact, this transform curve will also have this kind of general shape. So we can restrict it within the limit of x, that is x equal to 1 and x equal to 3. So that's why I have drawn the curve like this, restricted between x equal to 1 and x equal to 3. Let's now utilize the given information to draw the picture of the right triangle. As we know that one vertex is at origin, I have marked this one vertex at origin. Maybe you can call this as A. And another vertex is on the curve y equal to e power minus x by 2. So I have marked this another vertex over here. In fact, we could mark it anywhere on the curve, that is here, 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 anywhere on the curve like this. So let's have it like this. And one perpendicular side is along the axis, so you can see that this is the perpendicular side which is lying on the x-axis. So I have shown this in red color, and another one is parallel to the y-axis. So this one, suppose if I mark this point as C, so these are the two sides. AC is one side which is lying on the x-axis, and BC is another line which is parallel to the y-axis. So we now utilize this information and drawn the triangle, right triangle ABC. So we can understand that the C is the point or the vertex which has the right angle. Now we have to find the area of this triangle, that is the maximum as well as the minimum area of the triangle. So we could have many different types of triangle. Say for example, I could draw another triangle like this as well. So in this case, there could be the area will be different, or else I could draw something like this also. This is another such triangle. So these are all different triangles which could be drawn using this information. But let's stick to which I have drawn over here. So now we have to write down the area function, and using calculus we can find the maximum and minimum area of this triangle. So let's mark it over here. So in triangle, replace this color. So we have this triangle ABC, which is a right triangle. In this, to find the area, we need to know the base as well as the height information. Notice that AC is the base. AC is the base of the triangle, which is varying, that is x. The length of AC is going to be dependent on x. So it's we can represent this as x. And BC is the height. So which is given as y, because this height is also varying according to the function y equal to e power minus x by 2. So now we write down the area using the area of triangle. So area is half base into height. This is the area of triangle. Let me substitute the base as well as the height into this area formula. So this comes out to be base is x and height is y. The y is actually the curve, so we can replace this curve equation. So this gets simplified to half of x times of y equal to e power minus x by 2. So this is the area function. Maybe we can represent this as a of x. So we have to find the maximum and minimum area using this function. So now we are going to utilize the calculus, that is the first derivative, to find the critical point. To find the critical point, we have to find the a prime of x, which is the first derivative of the function a of x, set up equal to 0, and then determine the x. So let's do that. I'm going to use this area function and find its derivative. So let me find out the first derivative of this function, which is a prime of x. So here I have to utilize the product rule because it's a product of two functions, half x and e power minus x by 2. So let me use the product rule. So I keep the first function, that is half x, as it is, multiply with the derivative of e power negative x by 2, which is e power minus x by 2. And then applying the chain rule, we have to differentiate minus x by 2. Differentiation of minus x by 2 is minus 1 by 2. So I can put it over here. Plus, we then take the e power minus x by 2. Just keep this minus e power minus x by 2 as it is. Multiply with the differentiation of half x. So differentiation of half x is 1 by 2. Let's get this simplified. Therefore, we have a prime of x equals, this is equivalent to 1 by 2 times minus 1 by 2 is minus 1 by 4. And then we have x times of e power minus x by 2, plus the second term is e power minus x by 2 divided by 2. So this is the first derivative of the function, area function. Now we put a prime of x equal to 0. So I can substitute 0 over here. So I then have this every term. So I can just remove this and put this a prime of x equals to 0. We then have to solve for x from this equation. So let's get this simplified. So this is 0 equals, now I can factor e power negative x by 2 from these two terms. So I have this common terms. So I'm going to factor this out. When I factor this out, I have e power minus x by 2 times of minus of x by 4 plus 1 by 2. So this means either one is 0. That is either e power minus x by 2 equals 0, or minus x by 4 plus 1 by 2 equal 0. So this one is not possible because this will give an unbounded solution. So we can ignore this one. Let's use the other one to determine the critical point x. So this one is x by 4. If you solve for x from this one, you get x by 4 is equal to 1 by 2. This implies x equal to 4 by 2, which is 2. So this is the only critical point that we get for the area function. So we have x equal to 2 is the critical point. This means either the area is maximum at this point, or it could be minimum at this point. So at this point of time, we are not yet sure to identify whether this gives a maximum area or minimum area. Let's find the corresponding area when x equal to 2. So let me copy the area function. A of x is equal to half x e power minus x by 2. This is of x e power minus x by 2. Now when we plug in x equal to 2 into this area function, we get a of 2 equals 1 by 2 x equal to 2. So therefore this is 2 e power minus 2 by 2. So we can cancel few terms over here. This is 2 and 2 will get cancelled. And this is e power minus 1. which is equal to 1 by E. And we plug this into the calculator. Approximately we get the value as 0.368. Okay. So this is the area we get when plug in x equal to 2. Now we can also plug in the endpoints, that is x equal to 1 and x equal to 3. So when you plug in x equal to 1 into the area function, we get a of 1 is equal to 1 by 2 times of 1, x is replaced as 1, e power minus 1 by 2. So this is equal to e power minus 1 by 2 divided by 2, and this is equal to 1 by 2 e power minus e power 1 by 2, which I can write down this in terms of radical form as 2 times of root e. And plugging this into the calculator, approximately we get the area as 0.303. Let's plug in the other endpoint, that is x equal to 3. So therefore this becomes, the area function becomes EF3 equal to 1 by 2 times of x equal to 3 e power minus 3 by 2, and this is equal to 3 by 2 times of 1 by e power positive 3 by 2. So this could be simplified as 3 by 2 times of e power 3 by 2 is basically e times of root e. Okay, then we can simplify this and we get the value as 0.335. So now let's compare all these areas, and we have to determine the maximum and minimum area of this function. So I'm going to tabulate this. This is for x, and this is for a of x. So when x equal to, let's put the endpoints, that is 1, and this is 2 is a critical point, and 3 is another endpoint. When x equal to 1, it is 0.303, and when x equal to 2, the area is 0.368, and when x equal to 3, it is 0.335, which means out of these three values, this is the maximum. In fact, this has to be either maximum or minimum. So in this case, this is giving the maximum area. Since it is a critical point, at critical point, usually it will either be maximum or minimum. So this is the maximum, and compare this other values, 0.303 and 0.335. 0.303 is the lowest or the minimum value, which means this is the minimum area. Okay, so this is how we determine the maximum and minimum area of this given problem.